Yeah, so welcome everyone. So this talk is on Scala. Scala is basically just short for scalable language. It's been called scalable language for a couple of reasons. Firstly, in the sense that it was designed to be scalable in terms of your software design. So you've got changing requirements. Your software is ever growing, and it's got some very flexible features that make it very scalable in terms of your software design. And it's also scalable in the sense if you're making software that does lots of concurrent things, so many things at a time, it's very good at handling these heavy loads and in the way that they're organized. Okay. All right, so what type of language is Scala? It's multi-paradigm. So what I mean by that is you support multiple paradigms like object-oriented programming, so you can still make objects, you can still throw them around, call methods and whatnot. And the other paradigm it supports is the functional paradigm. So I guess functional is just another way of programming, it's another way of thinking about how you design, how you build your software. I guess as opposed to using more objects, you use more functions, you compose functions and how they interact with each other in that world. It's statically typed, it runs on the JVM. So the benefit of running on the JVM is it's fully interoperable with Java. So if you've got a project, let's say a Maven project, everything's all in Java, you can include it in there and it will work side by side. It's got absolutely no issues with that. You can use all the existing Java libraries. So if you want to use JUnit to test your Scala code, you can. If you want to build your projects using Maven, that's fine. You can, you've got libraries like Spring, so everything that you know and love, you can still use with Scala. You're not losing out on anything. So far as the IDEs go, IntelliJ, Scala IDE is basically Eclipse, but reskinned for Scala. I'm sure they've made some other changes in the background, but it's not an IDE I've used so much. So NetBeans, and of course, if you like your text editors, Vim and Emacs, they fully support Scala. And the syntax and everything, so you're not short on tools. Alright, so the REPL. REPL stands for read, eval, print loop. So if I just show you this, and it's a really cool tool that comes with Scala out of the box. You can start up the REPL just by typing Scala. So if you were to type some Scala code in here, it evaluates it for you and it tells you that it's created this variable of type integer and it's given it the number 5. Perhaps if I could make that a bit bigger for you guys. Okay, cool. Yeah, so it's created this variable for you. It's an integer. It's assigned it the value 5. So you can write code in here. You can test things out. For example, you can create lists and things if you wanted to create a list. Let's just say okay, so you can write code in here, you can create classes in here, you can do whatever you want, you can write Scala code, it'll evaluate for you and it'll just give you the output. It's a really cool tool. I use it a lot. Especially before I start writing code. And it's also good because the Scala standard library has so many functions, so many methods for their classes that it's a really nice tool just to be able to use them and get the hang of what they're doing. So it's a really nice tool. I wish Java had one. Unfortunately, you can't go and write Java code in here, so you couldn't write int thing equals 5. It wouldn't evaluate it. It's only Scala code, unfortunately. So. All right. So another feature of Scala that I really love, type inference. I suppose you've seen an example of type inference. I was typing in var x equals 5, and it worked out that this is an integer. So it will infer the types for you. And of course, if you like to be explicit, then you can say what the types are going to be. It will evaluate it for you just the same. So it's less verbose, I guess, if you're used to using languages like C# or Haskell or JavaScript or whatever. Those, if you come from that kind of background, you might prefer to just do it like that. So what else does Scala have? Immutability. So you might have seen that when I was typing in the REPL, sometimes I would type var, and another time I was typing val. And what this means is, if I create a val, it means that I can't reassign that value later on. So val to, I can't go and say now, I can't reassign it. That's it, it's done. It will always stay the same. I guess if you want to, you can think of it as as final in Java or whatever. And the opposite, of course, var. So var x equals 5. I can change x if I want to. And typically, when you're writing, I guess, Scala code, you're going to be using val or var. And so, as I've mentioned, Scala is multi-paradigm. So you've got your object-oriented paradigm and your functional paradigm. But within those, functional and object-oriented. Now, the thing is, the functional paradigm is a paradigm where you're not going to be doing a lot of reassignment. And the reason is because, let's say you're doing things like threading. If you've got global variables and things that can be changed anywhere, you can't really control the state of your program very well. Whereas, of course, if you've got immutable variables, then it's perfect for multi-threading. So, lots of benefits. So yeah, that's pretty much immutability or mutability. What else can you do? Okay, so another thing I really love about Scala is it gives me a higher level of a way to express myself when I code. So what do I mean by that? Well, usually when you write Java code, you have to tell the compiler, hey, if I've got a list or whatever, I need you to create some variable, initialize it to 0, and inevitably you're going to be accessing that element within the list, and you're going to do something within the list, So it's very, very low level. You have to tell the compiler step by step, hey, I want to achieve this, but in order to achieve this, you're going to have to go through these number of steps. Whereas the high level of expression, or what you can say a more functional way of doing things, is by making a function, maybe something like map, and this expresses something. So to map over something, right? To take a list and to go over all the values and apply some function. So I guess let's have a look. Let's create some Java class. I don't know. All right. So don't want this here for now. Okay. Okay, so let's say I want to make a method, and what the method is going to do is what should we make it do? Let's make a method that takes a string and tells me if the string contains an uppercase letter, for example. So I guess you could say public boolean, what should we call it? Has uppercase? Maybe? Okay, so what would I go... Okay, so I'm kind of guessing that a lot of people have written a for loop or know, what they're doing in Java. So if I was going to do this, how might you go about doing this? So what we want to do is return, just tell me yes or no if this string contains an uppercase letter. So how would we maybe start going? Yeah. Roughly what would we do if we wanted to get this going? Any ideas?
Basic approach will be find out each character.
Yeah.
And use character dot is uppercase.
Okay. Okay.
Very, very basic approach.
Okay. So go through each character in the value. I guess you could. Okay. And what did you say? Character dot is uppercase. Okay. So, let's have a look. You said character dot is uppercase. Okay. And I guess if we went through the whole loop and didn't find anything. Okay. So that would be a typical way you'd probably write in Java, yeah? You know? That's all well and good, but the thing is, you know, you've had to express how you're going to go about doing it, right? You have to go through each character, you then, you know, luckily there's like a helper method which will tell you if it's uppercase or not. I guess a similar thing in Scala. So if we make some, let's have a look, some string, So in here, what you can do, I guess, is let's have a look. I guess character. Maybe that would work. Okay. So essentially, I haven't in this Scala code that I've written, I haven't really said, hey, go through each character, check if it's uppercase, and then, you know, tell me, hey, this string contains uppercase values. All I've said is, within this string, if there exists some value for which this function returns true, then return true, otherwise it will default to false. So you notice that what I'm doing is, I guess, I'm expressing my problem in a high level in terms of I have functions that clearly express what I really want to do with this problem.
Can you test the negative?
Okay.
Can you test the negative?
Can you test the negative?
Some string all lowercase with a different variable name.
So if it doesn't contain a...
Or var string equals, or var string 2 equals Tuesday all lowercase.
like this.
Yeah.
Okay, there you go. Cool. Yeah, so I guess that's, you know, that's what I really like. That's what I really like about Scala. I mean, should we do one more? Should we do one more? Let's have a look. What if I had, let's say, something simple, a list of numbers or something. And I want to go through this list of numbers, and I want to keep it simple, multiply each of them by like 2 or 3 or whatever. So how, you know, let's say public void multiply by 2. Okay, so let's have a look. Whoops. All right, so how do we go about doing this? Well, let's create a list of numbers, I guess. Okay, cool. Nothing crazy. Okay, so what's gone wrong there? Huh. What does it say? Found Java util list. Oh, okay. Not quite so sure. Any ideas? Sorry, I'm a bit nervous, so it's kind of like my debugging skills are bad.
So you can just put the integer type in the like arrays dot.
In here?
No, like arrays dot triangle.
So you mean specify the thing in here?
Yeah, it might. I think it's on the other side of the dot.
On the other side?
Maybe.
Okay. Well, let's just assume that we have some list, right? How would we, I guess, go through here and multiply each number by 2 or 3? So what would be the first thing? We won't do the whole thing because it's kind of a bit long and laborious, right? It's kind of like, you'd go through each one, you'd say for int I equals whatever, and you'd say, you get each one, you manipulate the list, right? So that's what you do. But, I guess if you're doing it in Scala, did I create a list? I already have one. Nums.map. I guess you'd say for. Alright. Okay, cool. So that's gone and just multiplied each value by 2. So yeah, the whole point of, I guess, functional programming, we could have written our Java method to not modify the list at all. We could have created a new list and just stuff the new values within that list, right? That's functional. We didn't change anything. So I guess what I really like about this is you've got a new way of thinking. You've got a new way of thinking, and you can express yourself in less code and achieve the same things with arguably less difficulty. Okay. Cool. All right. So as I mentioned before, Scala is object oriented. So you've got classes with less boilerplate. So I guess if you were to create this class person in Java, you'd write all of your accessors and mutators and all that stuff. Whereas in Scala, if you look at the bottom of the slide, all you really have to do is define your variables in there, and your accessors and mutators are created for you. You have access to them throughout your entire code. So it's really cool. Less boilerplate. You might think that you don't have to go get a cup of coffee after writing those insanely long Java classes. So yeah, that's a really nice feature of Scala. You can of course override those. You can override the getters and setters if you wish. So it's very flexible in that sense as well. Okay. All right. So unlike Java, well, I say unlike Java, Scala is purely object-oriented. And what do I mean by that? Well, I can do things like 1.toString. And you might be thinking, hang on a second, 1 is a primitive type, why are you calling toString? You have to call it an object. Well, what Scala does is it will wrap, I guess, you can think of your, if you think of your primitives like int, int, boolean, whatever, it will create a wrapper for them, turn it into an object, and when the bytecode is generated, there'll be the equivalent bytecode will be using primitives. So it's just as fast. It's not like if you had a list of 1,000 integers, wow, I'm going through a list of 1,000 objects, which is way slower than going through just primitive values, right? So the equivalent bytecode will be those primitives. But in terms of, to the programmer, pure object orientation means everything is an object. So you can, that's the way you express it in Scala. And operators, so you don't really have operators, they're just method calls. So in this case, you see 1 plus 2, but what that's really doing is 1 plus, that's what it's really doing. So the plus in this case is a method or a function. It will take a value which is applied to the number 1 and give you your output. Okay? So it's really nice. Everything's an object. You've got all of these methods nicely defined for you, and there's a shed load of them if you look at the API. So you're not really, I definitely don't use a lot of them. If I'm honest with you, it's a very rich library. Okay, so singletons. Who here has ever written a singleton or still writes singletons or? Nobody. Quite a few people. Who here finds that they've written a singleton a couple of months down the line, they find out that it didn't work? There was a value for which, for some reason you had more than one. You do, yeah? Okay, cool. So, I mean, in Java it was kind of recommended that, it's good to just delegate singleton objects to the class loader. So in Scala, if you just write object and then your class name and you've got all of your class stuff in there, that effectively delegates the creation of the singleton to the class loader. So there's no way you can get it wrong. It's just not gonna go wrong. That's another thing I really like about Scala. Okay. All right. So Scala is functional, and yeah, well, for me at least, it's the best part. For a lot of people, probably not so much. So you've got first class functions. If you're used to using languages like C#, JavaScript, this is probably old news to you, but you can create functions on the fly and assign them to values. So I've written this one. And I suppose I can just, there you go. So you've got squared. I guess if you called squared on 2.2, you've got some double. which is cool. Let's grade it for you. So you've got these functions. You've got closures as well. It's closures, nothing too complicated in Scala. All it means is if you've got some global variable here, in this case num, which is 1, and that number changes, your function is going to see that update and give you a different value. So again, it's nothing complex. It's just a word given to sort of describe this process. So you've got closures, and you have higher order functions. So I guess this is probably arguably the most important part of, you could say, functional programming. So higher order functions, they follow the don't repeat yourself principle. And what that means is if you've got common functions performing common tasks, you can create sub-functions which sort of, I guess you could say, work on generic types and use them. I mean, so if a higher order function, typically it takes a function or returns a function or does both. If it's only working on values and returning values, it's not a higher order function. So if you saw a lot of the time I was using map, what map actually does is it takes a function which operates on the value and basically returns that output for you, right? So I guess that's a higher order function. And you can see that, you can create your functions and stuff them into these functions. That's higher order functions. Yeah, it's nothing complex. If you're used to writing JavaScript or C# Haskell, it's very, very common. The only thing I guess that will be different is the way you write it. So in Scala, just the way that it's written, it looks different. You'll see in the last example where I'm using map, you've seen that in the first one I've done X and I've declared the type int. Well, the designers of the compiler, they kind of know that, hey, if you're just working on each successive value in a list or something, then you're pretty much only going to be working with one type. And the reason they know that is because data types in Scala particularly are heterogeneous, so you're not going to have a list of like strings and person objects. You're only going to have one type. As opposed to Java, you can have multiple types that they're homogeneous. So they figured this and said, okay, well, why should you have to explicitly say it's an integer, right? We can just infer this. And they took it one step further to say, well, why should I have to write this, anonymous inner function x arrow x? Let's just replace it with something a lot simpler. They replaced it with an underscore and they called it placeholder notation. So the way it's written is slightly different, but the concepts are pretty cool. Yeah, hopefully it will return to us. Cool.
So I assume if you give it a long value, then it's going to infer that that's a long.
Yeah, it'll infer it's a long. If you give it a double, it'll infer it's a double. So that's really cool. So another sort of thing about functional programming is you have this concept called pattern matching. And I guess if you're working in everyday languages like JavaScript, if you're working with Java, C#, whatever, you'll write switch statements, you'll write if statements. Pattern matching is just another way to express those kind of concepts. So if we look at this function I've written, it takes an integer, returns something called a game state. So I guess if you thought of this as, hey, option one, a game menu, you've got 3 options. And what it does is it will match on the received input. So this is already inferred that it's an integer. So what you do after that is you can just call case, and then in the cases that the integer is a 1, 2, or 3, go about and do something. The underscore means that if this is something else, so if this was an exception, or if it was, I don't know, a string or anything else, it will just go off and do this globally for whatever the other value is. So pattern matching is really cool. Instead of writing switch statements and forgetting to include your breaks at the end, or writing some very, some nested if statements, this is a really nice way to write them. And what about collections? Well, you can also do pattern matching on collections. So if you take a list, you can pretty much case on the list and do whatever you want. So it's not restricted to it's not restricted to primitive values, I guess. It's not restricted to strings, integers, whatever. You can call it on whatever object you want and it'll do something. So that's pattern matching. So let's have a look. Other things. So something that I don't really do so much in Scala is scripting. You can write shell scripts in Scala. You can include your Scala in your shell scripts and run them, and it will pretty much output the same as if you're running a normal program. Scripting isn't really something that I do so much, but the tool is available to you if it's something you want to try out. So those were sort of the basics of I guess a very light introduction and the very bare bone basics to Scala that I use pretty much all the time. So yeah, that's just a light intro to Scala. Don't suppose we have any questions. Yeah.
What's the role of SBT in Scala? Because that was quite a painful thing to use. We use it in Play Framework projects, and it was probably the last bit about it. We didn't use Scala, unfortunately. We were forced to use SBT.
Okay.
Is SBT still as big in Scala as a build?
Yeah, it's very big. I mean, this project I set up as an SBT project, and you can tell I've got my build SBT. Of course, it's empty. I haven't included anything or done anything with it, but I haven't really found any issues with SBT personally. I guess if I'm including dependencies, one really annoying thing about SBT is if you include dependency, you have to leave a line below. They still haven't gotten rid of that, but hey ho, every tool has its bugs. Yeah.
I think if you were using it, we were using it in the Scala IDE,
Yeah.
and there's not a lot of support in the Scala IDE for SBT, which makes it quite painful when you come to do kind of creating RPMs or something like that. That's you have to use some magic.
Yeah. I mean, I did a test to see how painful SBT was. Obviously, this is sort of it's still pretty much very new to me, so I don't know about problems in the past of these tools, but I mean, I converted one of the projects that we work on here, one of the Land Rover projects, from Maven to SBT, and I didn't have a problem with it. I was able to take all the Maven dependencies, rewrite them into the build SBT using Scala syntax, and it worked fine. I never had any problems. There are obviously some quirks that you kind of have to, you can only pick up if you really read the documentation, but it's really good.
Play Framework has its own set of quirks that it adds on top of SBT as well.
Yes, I thought we were at a bit of a quirk festival when we were playing other things. Do you find now with Java 8 coming on, the functional interfaces and the lambdas and the streams and those flat map filter kind of functions, do you find yourself kind of being steered away from Scala, or are you still very much in Scala?
Still very much into Scala. Functional interfaces in Java 8, it's not functional in my opinion. It's just an opinion. It's not as flexible. You could say maybe it's functional. You could pass functions around, but
it's certainly not as terse as what you can do in that map stone.
Yeah. Yeah.
It's pretty impressive.
I mean, one thing I didn't talk about was traits. I use traits all the time. You can mix in what you call mix-in traits. So, I guess if it's an alternative to multiple inheritance. In Java 8, I don't see anything similar. So far as functional goes, I think there's still a lot of work to be done for Java. Yeah.
So function definitions, is it very similar to Ruby in that the last line is the implicit return value?
Yes, yeah, it is. Yeah, so my apologies, I didn't say that obviously everything, you don't really write statements in Scala. The things I was writing were expressions. And in maths, if you have a function always returns a value in maths. So it's a mathematical concept originally. So the last thing in your function will be the thing that's returned. Yeah, you don't have to use the return keyword. It's not. Yeah. Other questions? Yeah.
I I did the Coursera course, the Martin Dursky
Yep.
Coursera course, which was interesting, but I don't think it was probably the best way to learn Scala. What would you recommend?
Oh, yeah. So the Coursera course on Scala, I've done the course, and it's not really a beginner course. It assumes you already know some of these basics of Scala.
I managed to get around it, but I got to the end of the course and thought, now where do I start? It felt as though it should have been a project that you build up over weeks and maybe get to know a few more of the bits of Scala.
Yeah.
It's where it wasn't really like that.
If you, I guess the best tools to learn Scala, the first thing are the REPL. If in terms of books, programming in Scala, it's a very thick book. I'll give it that. It's very theoretical, and you can really, really play about in terms of the REPL. You can write Scala classes and use Java-C to decompile the class and have a look at the bytecode that's generated and have a look to see what the things written in the book are really true. I found that they are. So, for example, if I wrote a case class where you prefix the class with a case, do Java-C on it, you'll see that it generates your hash code for you, your toString, your equals methods. It generates your getters. You'll see the bytecode for that as well. Programming in Scala is the book that I used. Admittedly, I wanted to go right to the end and start using filters and things, but I would say that book is definitely, if you want to learn the bare basics first, then maybe another book would be Functional Programming in Scala. In Functional Programming in Scala, it will take you through sort of looking at lists and expressing, well, when it returns to us, you'll do a lot with, oh, is it really gone now? Okay. Yeah. Well, functional programming in Scala, you'll do a lot with higher order functions. You'll do a lot with things like currying. That's a more intermediate to advanced stage, I would say, if that's what you're doing. Yeah. So, like this example here, there's this method called fold left. It works on, I guess it's very generic, so it's going to work on lists of any type. You give it a list of objects that are of type A, you give it Z, which is of type B, and you see that this F just means this is a function that takes both B and A and returns me a result of type B. And all it's doing is it's folding from left to right on the list. It's folding from left to right on the list, and it's just applying the function to every element on the list. So if you work on a book like Functional Programming in Scala, you'll start writing more things like this, and things like drop while, where you pass a function in, f takes A, returns Boolean, and it obviously recursive, it'll keep applying that function onto the head of the list. So I guess if you're learning, that would be the next best stage to go, to really write functions and see how they work and what they're doing. It can get complicated, but we have currying, so it's okay. Life is good. Do we have other questions?
What have you been using it for? What type of applications?
Pardon?
What type of applications have you been using Scala for?
Have I been using it for?
Yeah.
So me personally, recently I've been writing an application called, it's basically, I guess you could say, a news aggregator of some kind. And I use Scala for this because I wanted to basically go off to loads of news websites like Sky News, BBC, Telegraph, Guardian. I wanted to grab all of the hyperlinks on there that relate to news articles and bring them back to me and show them to me on a page. Now, if I was doing this with threading, it would be a nightmare. But Scala's got features like actors. You've got actors, and you basically, they'll handle the threading for you. You just have to handle the message passing between them. And I think it's, I only implemented it for BBC, Telegraph and Guardian. I think it fetched around 1,500 articles, no duplicates, 1,500 articles in less than just shy of a second. If I was doing it in Java, when I wrote this application in Scala, it took me an hour and a half. If I was writing in Java, it would take me a weekend, if not more, if I'm going to be honest with you. I didn't have to deal with any threading problems. My classes were very small. My functions were, at most 2 lines. It was purely functional in the sense that I didn't have any methods doing side effects. That's what I've used Scala for personally. That's the biggest project I've used it for. Other things I've done with it, I made a baby rock paper scissors game when I first learnt the language. Again, it took me around half an hour to do. And the reason, and I'll be completely honest with you, when I was writing this game, I didn't have to use patterns like strategy pattern to say, hey, have I got rock paper scissors? What do I do on each one? And create a new strategy class for what happens if I've got a rock, paper, or scissor, or whatever. I found that passing around functions made it very easy, for me, to sort of craft that piece of software. I think that's probably the only one I stuck up on my GitHub if you want to have a look at it and see how it made life easy for me. One of my friends at Alpha Tech in London, so he's a team lead using Scala, and it's funny, they've got around 150 developers, and they've got almost a 50-50 split of functional Scala programmers and Java programmers, and I guess the downsides to sort of moving over to the functional paradigm is he can't just, he found it quite funny, he couldn't just sit the Java programmers down on one side and the Scala programmers down on one side and expect to have, and expect them to sort of achieve their sprints, you could say. He sort of had to mix them around. And what we found was the Java developers are actually writing more and more functional style code. So, yeah, they have a lot of code that doesn't see the light of day because it's purely functional, and the Java developers, they wouldn't be able to do anything with it. So it's not maintainable software, really. So, lots of companies are switching over to it. Guardian recently, their content API is completely Scala based now. Twitter's been using Scala for years. They switched over from Ruby, I think. Netflix uses Scala for their streaming. So, yeah, there are lots of companies using it. It's definitely not something to shy away from, if I'm honest. Especially if you've written at least JavaScript or some basic C#. So, yeah. Does anyone else have any other questions?
I think that's probably enough time.
Yeah.